Okay, section 5.3 is rate of change in slope. Basically what we're doing is transitioning over from calling our rate of change into slope. And the reason why we're doing this is because we're looking at data on a graph now versus looking at it on a table that we did from the beginning. So a rate of change is a ratio that compares the amount of change in the dependent variable to the amount of change in the independent variable. And the way we looked at that when we look at rate of change on a table is looking at the change in the y values. And that's just the, if I could draw it, let me try that again. The triangle symbol is the Greek letter delta, and that represents change in. So sometimes we use that as a shorthand form. The rate of change is the change in y over the change in x. And likewise, x and y are your independent and dependent variables. So if you're talking about the amount of change in the dependent variable, that would be y, versus the amount of change in the independent variable, that would be x. So as we're transitioning into calling these slope, it really is the same exact idea as rate of change. During our notes today, we actually skipped the bank account problem. We're going to look at that on a different day using some different values, so I'm going to just skip that one for now, but we will address that problem again. So basically, if we're talking about the slope of a line, most students when they're in 8th grade are introduced to the idea of rise over run. The rise is the difference in the y values of 2 points on a line. So when you're looking at the change in y, we're going to call that rise because that would be the direction that our graph would be going in on the x and y axis, versus the run is the difference in the x values. Is the difference in the x value of 2 points on a line. So then we say that the slope, which is just rate of change, but now that we're looking at graphs, we're going to call it the slope of a line, is the ratio of rise to run for any 2 points on the line. So our slope, one more time, change in y over change in x, which goes with the dependent variable and the independent variable, or as we like to think about it, rise over run. Now, 4 different types of graphs you're going to notice as we go through the different graphing processes. If you have a line that is facing in this direction, basically meaning that it slants upward to the right, this is going to have a positive slope, versus a line that maybe carries itself in this direction. That could be steeper or flatter, but it's basically going in an upward left or a downward, as most of the students say it. A downward direction would be a negative slope. Now sometimes we encounter lines that are straight across, basically a horizontal line. Lines that are horizontal actually have 0 slope. They still have slope, it's just 0. Versus a line that's straight vertical up and down, lines like this have no slope. And we have some cute little stories and things like that that we tell in class to remember the different types of slope: positive, negative, 0 slope, and no slope. And a way to look at it also is to think about walking. When you're walking along on the flat ground, on the flat surface, that would give you a slope of 0, versus going up a hill would give you a positive slope. Going down a hill would give you a negative slope, and if you're walking along a straight path and then boom, all of a sudden you run into a wall, you can't walk up the wall, although some of my students told me today in class that they felt they could do that. Technically, you're not walking up that wall, so it's not possible, which means it has no slope. So what we're going to do in this next little set is actually look at some points on the graph and determine what the rise over run is. And we're not talking about positives and negatives here, although that is very helpful when you think about that to be able to verify or validate your answer. Usually these graphs have dots on them, so I'm going to mark in some dots here before we get started, just to make it a little bit easier to do our counting. Let's see, I believe we'll have one there. Sometimes it's hard to tell on my grids. Let's see. Well, let me start out here with the first one on letter A. Letter A, we've got 2 points. So if you're going to count your rise over run, basically you can start with either dot, top or bottom, and just do the counting. If I start down here at the bottom dot, how many spaces up do I need to go to get even or level with the other dot in the problem? And that would be up 2. 1, 2 steps. So my rise is positive 2. It sounds weird to go down on a rise, but it is in fact possible. If you do go down, it would be negative. If you go to the right, it's positive, and if you go to left, it's negative. So for our run, we're going to be counting over 1, 2 spaces, and since that went to the right, that's also positive 2. 2 divided by 2 equals 1, so this particular line has a slope of 1. If I decided to count it in the opposite direction, meaning if I decided to start at the top dot and go down 2 first and then over 2 to the left, I would have negative 2 over negative 2, which also simplifies to 1. Therefore, you're going to get the same answer one way or the other. It's okay if you count in a different direction. All right, I believe I've got a dot at negative 2, 0 on this next line. I'm scanning up the line. I think I might see another dot. Let me make sure. How about here at negative 1 and 0. That's why it's really nice when these graphs already have dots on them. And what we'll do in the future, they'll always have dots on them, so it'll be easier to see. So I'm going to count my slope. Rise over run. Now I already recognize that this line is a negative slope because of what we just learned on the other side of the notes, and so I know that my answer for my rise over run, my slope, is going to be negative. I'm going to start up at the top, although you could start at the bottom, it doesn't really matter, and if I count down 1, 2 spaces, that would give me a negative 2 for my rise because I went down 2, and then over 1 to the right would be positive. Doing our division, you get negative 2. On the next graph, I believe we have a dot at 1, 3. And then if I'm scanning over in the line, excuse me, I think we've got, let's see, at 1, 3 and 5, 4 is another dot. It's super helpful when these already have dots on them. And the assignments that we do will definitely be that way. So rise over run. For this one, my rise, I'm going to go up 1 step, so that'd be positive 1 on top, and then I'm actually going to run over 1, 2, 3, 4, I believe. So if I go over 4 steps, that's positive 4 also. 1 over 4 is my slope. Now remember, you can count it backwards. If you start at the top dot and go down and over to the other one, it would just simply give me negative 1 over negative 4, but of course that reduces to positive 1 over 4, and that's my slope. On letter D, I already know that this line has 0 slope. I know that because we learned that on the other side of the page, but just to verify mathematically, what if I put a dot right here and I put a dot right there? Well, my rise is going to be 0 because I'm not having to go up any to get to the next dot. So I would have a 0 on top, and then the particular dot that I chose, if you go over 1, 2, 3, 4 spaces, that would be positive 4. If you divide that in the calculator, 0 divided by 4, you get 0. And so that's why 0 slope, even though we just know it because we memorize it, mathematically it does actually work out to be 0. We already know that this one is no slope, but again, mathematically, let's see why it's no slope. Some people do say no slope is undefined. That is an also acceptable way to write it. So if I do my rise, again, picking 2 random points, I'll just pick 2 that are pretty close together. The 2 that I picked would cause my rise to go up 2. My run, in this case, would be 0 because you're not going over left or right any. So if you use a calculator and you divide 2 divided by 0, you're going to get an error message that says undefined. It is not possible to divide things into 0 groups, therefore it is undefined when you try to do that. For our slope purposes, we say that this line has no slope. And then finally, one last little check here. A line going straight up and down would have a slope of 0. A line horizontal going back and forth would have no slope. And one that goes up in a right direction would be positive. So that's taking a look at slope and doing the counting of rise over run from a graph.